2, 3. Okay, let's get it started. Hopefully we're gonna manage because I have plenty of slides. Anyway, welcome you on my presentation. Before we start, I do want to know about something about you. So who comes from the JVM.Java world? All right. Anybody with Golang experiences? Cool, you already know everything. Python, C++, nice. Front-end stuff. Okay, cool. Okay, so today I'll try to, I'm inviting you to embark with me on the journey, trying to answer if Golang is a safe harbor for every Java developer. Is it the promise that this is a language making programming fun again, meaning fast both for compile and execution time, universal, meaning targeted platform, and for the appliances, need concurrency model, etc., whether or not this promise will be fulfilled. Just a short info about me. So for a couple of years, like more than 10, I was doing stuff in Java, JVM, also some managerial roles, and now I'm a Golang developer for about a year. And on my website, you will find more than enough ways of contacting me. I do really enjoy reconnecting with you guys after such an event. First thing first, I'm not here trying to convince you or sell you the Golang or the idea. Far from it. I'll try to present my perspective after 1 year with Golang, what are the typical pitfalls to avoid, misconceptions about the language, and maybe also about being a polyglot programmer. Speaking of which, why even consider a second or another language? I have to go back in time a couple of years ago when a friend of mine said, well, there is this great book, Learn Your Haskell. We shall use it, we shall learn it by heart, and we shall tackle the Go code contest. And we did. And we failed miserably because we were struggling with the language itself. But still, that was for me, and it was like more than 10 years ago, it was a pre-Java 8 world. So for me, I was not pretty much aware about things like tuples, pattern matching, carrying higher order functions. I didn't even was able to correctly think in a recursive way. So that was an enlightening experience of undermining or challenging my current state of knowledge, from which I derived, well, learning other language, even not for production ready, is always a good thing. Same as Tomasz Nurkiewicz said that when you are in Java, you probably would like to learn Scala, even if you will not deliver in Scala. It's a much harder or different mindset that you will cherish and enjoy broadening your perspective. And I still recommend that book. There are also more basic, mundane reasons why to pick up the second language, like feeding your family. So I just had this opportunity to join the project for Cisco, where they have a microservice mesh written in Golang mainly, which is kind of a feat because it's there are microservices older than 10 years written in Golang, so we can consider it even a legacy, which is not that common on the market. Speaking about the foundation, just a brief overview for those who are not aware. It all started in Google, which is good and bad, because we all know this page, killedbygoogle.com, and that's something in the back of my head that, well, will they kill this eventually or not? How it goes? It's a tricky question. We can discuss it later, but it started in 2007. Then 2 years later, it was announced publicly, and the first 1.0 version was released 2012. Language backed by some remarkable persons like Robert Griesmeyer, Rob Pike, Ken Thompson, well-known and recognized engineers. Okay, so very key foundation stuff, like similarities with Java. So it's a C-based, Golang has a C-based keywords, but don't be misled by that, meaning it's not yet another C++ for the 21st century. Originally, I think it was Rob Pike who said that we were aiming to our target audience to be a C++ developers, but it turned out it's not the case, because C++ is packed with features. Each release is giving more and more stuff, and people are used there to accomplish things in a very specific way. So migrating to Golang, which is way simpler language, they would have to give away a lot of what are they used to. So it turned out like it's easier to transition from like Python developer to be Golang developer. Java, we'll see. Has static typing, type inference. It's compiled. It has a GC and ensuring some level of memory safety, but it has no virtual machine. So it's about finding the sweet spot that, okay, we are compiled, but we would like to introduce this garbage collector which will take care of all those memory nitty-gritties, whereas not giving up too much of a performance and not and just to deliver, basically. There is no inheritance. This is something I will circle back in a moment because it's important to understand when you are switching from the strongly OOP-based languages like Java to not have this misconception of how this is, how you can achieve something that resembles inheritance. Need dependency management, like kind of done by accident, but it turned out really pretty well. It has pointers, which is always scary, but we will take away that fear in a moment. I think the majority of the glory is taken by the concurrency model in Golang. The people are cherishing it for the simplicity and readability of it. And there are no exceptions. We'll see that in a moment. I mean, having small set of reserved words, it's not the only reason why the language is simple, but it's one of them. So there's only 25 of reserved keywords. Highlighted are those specific, not existing in Java words. I know that goto is reserved in Java, but it's not really used. Golang implements goto, which is kind of unusual to such a fresh language or new language, but you probably shall not use it, but it is done in a neat way. Like it will not allow you to jump over the variable declarations, do nasty stuff, etc. So it's a go-to in a 21st century flavor, but still don't use it, forget about it. Maybe in some mathematical operations it might be useful, but let's like, okay, so what can we actually build with Go? So it's derived from their official documentation, nothing really unknown. So cloud and network services, strong ecosystem, the ability to ship the binary even without using the fleet like ECS, etc. It's quite convenient way to provide, to create a mesh of microservices in a cloud solutions. Command line interfaces, more and more are written in Golang with popular open source packages. To create this fast, elegant CLIs. Web development, so it was backed into the core of the language, the awareness of the not the HTTP layer and stuff. So it's pretty convenient to write web powered by Golang web services. There is a support for popular IDEs as well, which helps a lot, and DevOps and site SREs. Still, the feasible way of shipping your, I know it was troublesome for people to share, like, I think Ruby, Python might be as well an issue when you try to instantiate the environment of execution for your scripts to be shared among your colleagues. With Go, it's simple. You are shipping just the binary self-contained file, and that's it. So fast build times, lean syntax. It's nice to be used by DevOps and SREs. Some serious stuff can be built by the Golang. You are probably already familiar with, I mean, the most significant ones like Docker and Kubernetes, probably the most hated ones as well. By the way, in Cisco, we are still using Docker Swarm, not really intending to migrate soon, but we'll see that. There were some POCs on that. Okay, so if you want to literally start the fast track, then you can hit this page even on your mobile, tinker around with the Go with different versions, some code examples. If you combine it with Tour of Go, if you have just, for example, like a couple of spare hours, you don't know anything about language, you can reach out to this page, and it's a matter of, like, I would say 2-3 evenings with this Tour of Go, and you are pretty aware of the basic concepts behind the language. But to start for real this time, and to explain some basic ideas behind the Go, you are creating a first source file with main function and like printing something, really stupid example, but anyway, then you are instantiating the module, and that can be tricky if you are, for example, because in general, in Go, you typically have one module in your project that consists of one or more packages. And the naming is the opposite how, for example, in Node.js is doing, but you get to you will get used to the naming convention for Golang, I would say. Go building and running. You could see that I used the /cmd sub package, which is a typical pattern. There is no like official template of how you have to structure the Go code base. But if you are writing a CLI or other type of services, it's typical to put your main execution inside the CMD folder. For example, if you will be working with web-based applications, you will probably encounter the HTTP listeners, HTTP handlers folder, etc. But there are no strict rules around that. And there is a Go mode file which describes the module, which especially if you are thinking about publishing it, you shall be unique. And this uniqueness is pretty nicely achieved by using the URL to the repository where the code resides, which also is convenient for like Go-Get tool that is fetching the dependencies, as well as for contributing to the projects. You are very it's simple to go to the GitHub or any other provider and see what the code base for this specific tool is, and Go version, and then some. For now, those are omitted, but require statements describing the dependencies. Speaking of the dependencies, so you probably already noticed that I like to generate images in an AI. It's nice in Bing. Anyway, those broken jars shall depict the broken mechanisms in Java. I mean, you sometimes feel like you have to have a PhD in Maven or Gradle to just handle the dependencies, and still you will get shot in the foot by some runtime problems because somebody should inappropriate entity there, here and there. Whereas in a Go, it's typically just a self-contained executable. You can send it over the email to your granny and she will run it. I mean, yeah, something that can resemble the I would say GraalVM project, like ahead of time compilation stuff for Java. I mean, I cherish the JVM world. I still keep my finger crossed for the Java and for its development because it's going pretty well. But this self-contained binary is pretty awesome, and pretty nice feature is the cross compilation. I'm not sure if this is visible, but it's not important that much. Basically, I've just printed out the whole combination of OS and architecture I could achieve on my Mac that I can cross-compile to the different targeted platform. And just by orchestrating with two variables like GoOS and GoArch, I can then build it's really not visible, but this is a jtgo.exe file that can be run on the Windows machine. So it might get tricky when considering the CGO, so the native C++ code execution, but in general, it's a nice fit and a bold statement. But Rob Pike, the creator, said that given the way the assembler works, I don't know what are the internals, but his bold statement was like, it's pretty easy to like add, it's as little as a few hours to add support for new OS architecture. He was probably flexing to some extent, but yeah, nice to know that it's not it's rather trivial than cumbersome. Okay, so let's see some Go code and start with a rant. Like it was my first experience. I opened the code base and I was like, well, it's so low level. It's rubbish. Like, and the guy named Primogen, he was ranting about that. I strongly recommend his podcast and other stuff. He gave this example because it's a real production deployed Gorilla WebSocket implementation in Golang, and he said, guys, I know this inside out. I read the RFCs. I know WebSockets really well, and still he was struggling like one letter variables, this NN bullshit on the right hand side. I mean, come on, it's hard to read, how to comprehend, wrap your head around it. And this is a thing for the Golang. After almost a year, I would say I'm kind of used to this, but yeah, I would not say it's a convention, but this is how it goes. So, especially if you are coming from the verbose language, you get used to those lengthy names in Java, well describing stuff. It's the other way around. Okay. Yeah, sure. No, you can. I mean, I don't know if there is any upper limit, but yeah, it's just it's the nature of Go developers, I would say, not creating stuff. And about the Go itself, again, it's very idiomatic language, so it's simple, yet there are some concepts that you call an idioms in the language. For example, here is a comma OK idiom on the right-hand side to check if something is present under the specific key inside the map. It's also used for checking if the channels in concurrency are available and ready for being received the information. Anyway, that's just an example. If you have to take away only one source of knowledge about the Go after this presentation, I would strongly recommend this book by John Bodner. It's great. It's it's not the entry-level book of, oh, I would like to today to learn you how to sum two numbers in any given programming language. He assumes that you have some knowledge about programming. He presents the idioms. He presents the real-world examples. I strongly there is a second edition that was released recently, so I strongly recommend. One of the last slides from my presentation will be gathering all resources I mentioned, so you can wait until the end of the presentation. There will be a QR code and stuff. So. I don't want to bother you, but just a basic concept to explain some more sophisticated ones. So type inference, so we already have this var keyword in Java, and I would say compiler is getting smarter and smarter, and the same for Go. The first line is pretty valid, Java, sorry. Go code, you will also encounter the second version of it, but for me the last one is very common. I mean, sometimes verbosity is nice, but having this ability to infer the types, still remaining the strongly typed language is a perk, I would say. Receiver functions, so kind of thinking of them as methods, I would say. So if you have a structure that defines your, let's say, object, and you want to add a behavior on that data that is storing, you are creating the receiver functions, the two that are being displayed right now, and it can have two flavors. Famous pointers to be considered, because the second one is using the asterisk sign, meaning you can mutate the state of because by default in Go you are passing by value. So if you want to explicitly mutate something, you can pass in the pointer and then do some mutations. Regarding pointers, I would say, maybe you can talk about later, but basically pointer overuse can also be a foot gun for you, and you have to be very careful. John Bodner, from that book that I mentioned, said that taking to extreme, pointers shall be your last resort. You probably don't want them in the majority of your use cases. That's, I would say, okay, let's cherish the concurrency model, but I would say, please be aware about the type system and how Go is designed when coming here from Java world. Basically, I saw that people were trying to misuse the inheritance, trying to mimic the inheritance by some nasty stuff here, but it's required you to change your way of thinking, even starting with interfaces. So the interfaces are implicit, and that was the intentional design choice. In Go, I mean, we can discuss it, but they try to find the sweet spot in the middle of static and dynamically typed languages. So they achieve the decoupling by the structure is not aware that it's implementing some interfaces. Yet it's explicit that how the interface is implemented. So there are no like implements keyword and stuff. It's simply by, okay, if I have my interface with the method defined, then for the structure T to implement the interface, I have to create the receiver function that satisfies the interface. That's like paradigm shift that can be tricky at the first point. For me, it was like, for example, in Java, you got those bloated. I mean, not always, but the interfaces tends to be bloated to contain the fairly large contracts, and they are explicitly implemented by some objects. Whereas I just borrowed / stolen this example from John Bodner. Implementing the interfaces in Golang is about that. Typically, the client or consumer defines the contract that he would like the incoming object to fulfill, basically. So it promotes the small atomic interfaces closely tied to the caller, and that the implementing, like the structures itself are untied from this. Of course, it can get tricky, scattering the implementations around the code base, that can be tricky. But also, it doesn't mean that you cannot have the shared interfaces. Like there is a common interfaces like writer, reader that you can implement, reuse. If some from the SDK itself, some interfaces fulfills your needs, just please use them. That's totally fine. So is it an object-oriented programming at all? By the way, do you get the reference to language at the bottom, at the top? Sorry, it's a LOL code, the esoteric language, programming language. I mean, yeah, speaking about the polyglots, so a lot of different languages here and there. Anyway, so yeah, kind of. It's not. I would say you got an ability to encapsulate your data in a interesting way. We'll see that in a moment. There is a polymorphism, but like achieved by interfaces, and there is this last statement, composition over inheritance. It's like there is no inheritance, basically. That's an important part. And I saw that Java guys are trying to reason about the next feature I would like to explain. So composition by embedding, to consider it's okay, it's inheritance, but it will be a food gun for you because it doesn't work that way. So basically, that's a trivial example on this animal stuff, but please be advised, and I will explain it in detail, that embedding is not an inheritance. And there are two outcomes from that. So I try to use the virtual one. Yeah, oh my God, it's shaky. Anyway, the first one you cannot do. I mean, it's typical that you can think of like, sorry, wrong direction. So having animal embedded into the pet structure doesn't imply that you are creating any kind of hierarchy. It's really detached from anything that you can consider inheritance. You have to explicitly assign it to the pet embedded structure. However, by embedding, the methods from the embedded structure are promoted to the containing structure, meaning it can, by embedding, you can fulfill the interface for the given object or the structure. So that's important. But there is no notion of dynamic dispatch in Golang. Meaning, for example, there is, it's other example of embedding. If it happens that, for example, our inner structure here, this guy, has two functions, and it happens that the structure in which we embed the outer one has also the very same name of the function, and we call it that way on our structure. The inner structure basically does not know that it is embedded. So there are no dynamic dispatching. It will be just the int printer from the inner code. So that's very important, that there is no inheritance and stuff like that. There is embedding, which is kind of nice. You have to get used to this. But yeah, that's an important remark. Another paradigms to discuss. So functional programming. Is it a functional language? Kind of. It's not pure functional language, but it gives you the nice tools from the functional programming toolset for you to be used, basically. So the functions are the first-class citizen, meaning they can be assigned to the variable. You can pass it to the function. You can return it from the function. So you can have those higher-order function stuff. There is a notion of you can use the func keyword to create the anonymous class that is holding the surroundings with closures, but like features, they are not native to have features like in a concurrency world, for example, like futures, promises, stuff like that. There are, I think it's a third-party library that tries to mimic the behavior of a monad. I don't know what monad is, so let's forget about it. Let's say that you can have, to some extent, some functional nice stuff there to be used. And speaking of, I will try to combine the two things. Like, there is a promise of backward compatibility. The Go creator said, we don't break stuff much. Like, if there will be some serious issues, we'll try to implement the backward incompatible changes to tackle the known issues. But in general, we try to keep our go very clean in that manner. And there was a case for very recently, for loop has changed the behavior in Go 1.22. So there was an issue that if you have a for, I mean, it's not only for concurrency, but I have introduced this example from the documentation where you have to, we are using this Go keyword, which is spawning the lightweight, not thread, but entity of execution that is called Go routine that can run concurrently. And then we are waiting. This is also the syntax sugar, like this arrows meaning the reading or writing to the channel that can be bidirectional. So we are just iterating over those values and trying to wait for all Go routines to block on receiving the results from it. And before the Go 1.22, of course, there is a notion of like contained surroundings in the closure for that function that is defined there. With that Go pre-Go 22, we'll see something like that. Not guaranteed to be the C, but basically it was the issue that the for variable was the object of a for variable was reused. So at the end, instead of expected result like ABC, you got something like this. There were workarounds, like you have to explicitly, for example, here, you would pass as a parameter the value of the current variable of iterator and reassign it explicitly. That was like a stopgap for fixing this. But they decided it's too common, it's shooting us in the foot, so, or other vendors, so let's change that. And eventually, with the new Go, the result will be printed like this. I mean, the order is not guaranteed because that's the nature of the Go scheduler, but it's not trivial. That's an example when that was an issue for, it was the Let's Encrypt bug caused by just this very issue that Go had. There are tools that are written to identify, but it's hard to analyze whether the reference to the variable outlived the iteration or not. Those tools tend to either has a false positive or false negative, so they just decided to fix that by the nature of how language works. And Guy in Let's Encrypt was aware about that issue. He reassigned explicitly one of the variables, but on the second line of code, he passed the reference and it was mutated and stuff broke. So basically, even though if you are a skilled developer, it's nice that they kind of broken backward compatibility, but you have this on a per project, you can set the Go mode version differently, or even per file. There is a meta value that you could set to treat different files differently. I would say Go is speeding up. I mean, it's like, of course, very, it's my opinion, but basically, for a long time, for example, they were holding off with introducing the generics. And they did in Go 1.18, and then more and more stuff that I would say the velocity seems to be increasing. The for loop change that we have discussed, the very recently added iterators, we'll see where it goes, how the Go will maintained by the Google or will be taken by community. We'll see how it goes, but yeah. So another thing that people are complaining sometimes or always or a couple of days times a day is how errors are handled in Golang. So there are no exceptions like in Java. The error is just in value, and you can even implement the error interface to enhance what is returned by when the function returns the error, and it's exactly same value as other objects. So. It's bloated. I mean, it blows you when you see these if statements, and that's also an idiom that the error is the last returned value. And that's another neat part about Go, that you can have multiple return values, which gives a lot of flexibility, for example, compared to Java. And but it's idiomatic way that you return the error at the last position. It's not obligatory. Pointers, we have discussed this already. I will just swipe next to the slide. The syntax is very common if you're coming from the C, like there is an ampersand, there's a star to the reference stuff. You can change the values, etc. Pointer arithmetic, you just don't do it, please. But basically, there is an unsafe package, not only containing pointer-related stuff, but other as well, that allows you to do this tricky part of handling the memory. They are even developing this package actively, like introducing this unsafe add that hides under the abstraction the possible problematic parts of handling the pointer arithmetic. But okay, let's be realistic, you probably don't want to do this. Another example where I explicitly saw that somebody was struggling because he was trying to understand that, okay, constants, set of constants, then enumerations, right, like Java. So there is a notion of iota. By the way, it's derived from the Greek letter from the APL language, so yet another language in my talk. So, okay, we can do this in an idiomatic way. We are defining the direction, we got the set of constants there, and we got this nice receiver function that is changing the, basically printing out the string representation of some iota enumerated values. By the way, this type definition is not required, it's just a convenient way of displaying it. But, and it looks nice, it looks really enum-like stuff, but it can get tricky. For example, do you happen to know what will be printed there if we try to implement this in this manner? So it will be printed, what would be printed will be 0 to 2024. Because iota is just a way to tell that I would like to count, generate some sequence of numbers based on basically line numbers in the constant block. I can skip the lines, I can mutate the value of the iota by some mathematical operations or bitwise operations. Some people get really have this they try to be smart and implement some bitewise operators to just cope with some iota enumerations. But one important takeaway is that iota is basically when you care about this distinct set of values, but you are not interested in values itself. Meaning there is no guarantee that nobody will alter the order of your enumerations, add some new line, and then if you just rely on what is under the hood, meaning the numerical value, then you are screwed, because that's not the intent for using the iota. So that was another thing that, comparing to Java, is important to understand. Access modifiers, pretty simple. Someone hate it, someone love it. It's pretty much common in Golang, like various elements of the languages, like love it or hate it, take it for granted or not. So by upper or lower case being defined as the variables in your structures, you are saying if uppercase is the first letter, then this will be exported, the lower letter will be unexported, and that's it basically. Slices, so that's another nice part of the language. I just went over not commenting about how the arrays are compared to what's in Java. One important remark, size of an array, standard array, is a part of this array type, which makes that a little bit strict in terms of how they are handled. But let's disregard this. If you would like to have something very flexible, there are slices. So this is a slice taken from this prime table and printing out the slice. You can instantiate the slices in a various way, like using the make. Slice literal is also allowed. You can create slices from slices, etc. Important notion is that there is length and capacity. So how many elements are inside the slice and how many more can be inserted, but there are no upper limits. That's important if you are coming from Java, that you understand that slice is just a wrapper around the underlying array that backs the whole slice stuff. And just a simple example, you can have a slice like with length of 2 and capacity of 4, containing some values. It doesn't matter really. And you can reference the very same variable of slice by second slice. And that's it, it's fine, okay? Then we are mutating the first element of this part of the memory, which will lead to the situation the address of the underlying array will not be changed, and the slice B and A will have those value mutated. But you can do something more. You can do this appending, and for example, if you append to the slice B the 3 elements, it will exceed the capacity as described in this slide. which will mean that, okay, now Go has to extend the capacity, so slice B will be pointing out to the different area in memory, because the underlying array will be a new part of the memory. I already saw that this is that can, if you are not understanding how the slices work, that can be tricky for a daily job when coming from Java or other languages. So that's about the slices. Overloading methods, it's simple. You cannot. Another hate or love. You cannot overload methods by varying arguments, count, etc. You have to be very explicit. So like you have to write 2 separate functions to cover you. So yeah, love, hate. This is how it goes. So I mean, this will be like very like, I don't want to be this talk to be a crash course in Go. It's not the intent. It's just remarks on what I've seen from 1 year perspective. But I just want to leave you with some basics. So famous concurrency model. You got Go routines that this Go keyword we already discussed, that is spawning this I would say entity of execution, because Go is originally about the concurrency. You can enforce how it works in a parallel world on a multi-core values by some setting with the environment variables, etc. But basically, it's not directly equivalent of the project Loom in Java, but it somehow resembles the idea, right? Go routine initially with a small footprint. It can increase when you are like packing it with some more scope variables and stuff, but basically lightweight units for concurrent execution. Of course, don't use time sleep on your production code or even in your tests, which is, it's really forbidden. It's pain in the ass. Anyway, and having the Go routines, but one maybe important or not remark, like for a couple of months since I started writing Go code for a serious customer, which is a Cisco, I wasn't even enforced to use concurrency in Go. Like, yeah, it was like not needed. Anyway, you still have this notion of channels that are messaging tracks for communicating between Go routines. So this is a very simple example when we are trying to make a summary by slicing our input data that needs to be summarized in the variable into two separate Go routines, and then this famous arrow syntax that is waiting for receiving from a channel, and the outcome on the right-hand side, basically. Just sliding through this topic, that there is by default the channels are unbuffered. Also, I mean, by no means I consider myself an experienced Go developer, so I do not even had an opportunity to work too much with buffers. But the two use cases that might be interesting are those when you would like to, when you know exactly how many Go routines you will be spawning, and to read from it, basically iterating over the buffered channel, reading out the values as they are written. And the other is the back pressure mechanism, which can be used for like not overwhelming our systems with incoming data. Sometimes you need to wait for a couple of Go routines to be finished, basically. So then the wait group is kicking in with some value describing the expected Go routines to be completed, and that's it. Having the Go keyword, I would say channels and wait groups, that's it will get you covered in majority of the use cases that you will encounter at the first when embarking on the language like Golang. And this is exactly a classic anti-pattern of a slide for a presentation, so I will blur this. Basically, what I would like to present here is that you can really go far with the standard library. So by the things that are backed into the language, like having this web layer decoding operations over the concurrency and parallelism, you are pretty much secured in terms of not even simple, but medium-sized project, I would say. Of course, there are some limitations. If you would like to have some more sophisticated routers for web, ORMs, like messaging queues, etc., then, for example, yeah, for sure, we would like to use the third-party tools, but the community is great and the tools are evolving. So, but yeah, I really cherish the approach they took by creating this very robust standard library. I really enjoyed it. I don't have a strong opinion on that, but I heard this over internet. Really, I'm just using the IntelliJ stuff, so they have their own representation of the source code tree, etc. But Go, please, the Go language server, I think it's Primegen said that it's almost like those LLM stuffs, like it's trying to predict the autocomplete for a couple of steps ahead. So not having strong opinion, it's rather the slide to express gratitude that they took those moments to build the tooling around the language, because I would say great tooling ecosystem is the thin line between life and death for language. Language can be brilliant, but if you will be lacking the tools, the ecosystem, it will die soon. But the Go creators were aware of that and investing time in that. There was a talk by Bob Pike that is no longer a contributor to Go, but he was kind of summarizing what they did wrong and what they did right in terms of Go, probably focusing on the good parts, I would say. Even took like 10 minutes talking about the gopher, the mascot, that it's great that they had it, and like that was kind of weird, but yeah, and he complained that the gopher is under the Creative Commons, which led to some various modifications of the gopher mascot and some weird stuff. Anyway, let's not talk about it. Anyways, I agree with him on this standard library stuff, the concurrency model that is pretty easy to be absorbed by the newcomers. That was actually the additional, I read some paper on it, that in Google they was trying to have some simple language so that the velocity of the newcomers is increased. Like basically, the simpler the language we got, the more stuff can be done in a shorter period of time, basically. About the formatting, that's something I haven't said, but it's really nice. There is a standard Go formatter, so the holy wars can be ended. So we do not focus on how many tabs, how we format our code. Basically, apply the Go format and forget about. Let's focus on the stuff that matters. Basically, I really like this attitude in the Go ecosystem, I would say. Something that I haven't presented, the testing tools. That was something that I haven't thought about, but considering they started the language in 2007, and I recall myself from that period, it was really not that common to have this fully fledged test suites of different kinds, of different layers, etc. For Java projects. That was the Wild West then. And they, even though by starting this work on the Go, they bug this inside of the language. The testing framework is so neat that there is actually no excuse for not writing a test anymore. So it's good to cherish the decisions they made at the beginning. Okay, so I would say about the community. For example, I can recommend the Go Time. It's a great podcast. They are inviting a really tremendous guests. And for example, if you are tired, having not much time, father of two as I am, then you can just play it out loud on your car or something. So it's great. I do recommend the Gophers workspace on the Slack, because besides some news from the language, there is a job section. So if you would like to have some major changes in your life that will consider Go as a part of it, maybe job posting is the way you to go. Also, before summer holidays, I attended the Java user group with Bartosz Paluszkiewicz. He was doing basically the talk about the same stuff as we are discussing today. Unfortunately, there was a Golang group that is no longer active, but that was nice to see the guys from the other company that they are not using Golang as a daily driver. If I recall it correctly, it was the case where they were not able to handle the huge payloads in their microservices written in Java, and it was just working out of the box in a Go, and they decided to go that way and implement the side project to some operations by just using the Golang. So it's nice. I mean, really, let's cherish that, and I hope that more and more people will be getting involved in this technology stack, just to share your thoughts and. Yeah, let's hope that Go will not kill the project of Golang, and we can work more on this language. So just to maybe point you out to some areas that I haven't covered today, after leaving this room, definitely read and find more about how context can be used. For example, sometimes you also need to use the mutual exclusion. There is an abstraction for that, mutex. With context, there is a context cancellation pattern, very common. Selecting on channels, this another option. Reflection, as we used in Java, there is a notion of reflection in Go as well. More is yet to come for you if you dig into the unsafe package, beside this nasty manipulation of pointers, I would say. CGO, so the native code of C++ execution. One remark on that is probably about integration with existing code bases, then gaining some velocity or gaining some speed in terms of code execution. So that's the reason why this module exists at all. Testing, as I said, there is no reason for not test anything because it's a part of the feature. It's a feature, a part of the language. More on tooling, the stuff. Oh, by the way, about tooling, the promise of backward compatibility is not applicable to the tooling. They already broken this several times. How input parameters are handled by Go tooling mechanism, etc. So be aware about that when you will be building some maybe automations around the Go pipelines in your cases, etc. Immutability, that's another neat part. There was even a proposal to introduce the language level keyword for ensuring the immutability. For now, that's not the case. You have to be very cautious about that. Takeaways. I would say unlearn. So to avoid this typical food guns, I mean, not only for Golang, of course, but basically not being biased on doing the exactly same thing in the exactly same way in a different technology might not be the good idea. Like recreating what you have already seen. Cherishing the new language, that's something that I can reflect on what learning a part of the Haskell did to me, like definitely sparked some ideas around the concepts that I wasn't really aware of and not really putting an effort to learn them before that. So yeah, that's a great part of it. Seeking for idiomatic way. Definitely, if you have this feeling that you are struggling, your language is fighting with you, then probably there are two options. Basically, one is skill issue, and the second one is that you are using something in a not intended way, designed by creators on how to use it. Yeah, be inspired by new concepts, I would say. And lastly, you are not too old. Maybe it's a remark to myself because someone said, "Oh, Michael, you will be learning Go. It's a midlife crisis for God's sake." No, it turned out really nice. I mean, like, I think it's never too late to just see some new stuff and try other things. Even though if you are not end up by contributing to the production-ready code, it's a great way to learn and grow as an engineer, I would say. That's the last slide I've mentioned. So there is a QR code. It will lead you to my GitHub gist where I just listed a couple of interesting resources. So there is a nice book. It's also a website called 100 Go Mistakes, which maybe some are trivial ones, but basically it's a nice way of learning by learning on someone else's mistakes, especially someone else, because on our mistakes it's always the hard way. The tour of Go and Playground, I said about it. I also recommend, if you are not familiar with the Fireship guy, he has a great content on various topics, basically. Coursera specialization, I would probably remove that one because I've done it, but I didn't really like it. I mean, the pace of it was way too slow. Piotr Przybył was giving very similar talk on his approach for Go from being a Java developer. Effective Go as well, Time Podcast I've talked about. And once again, please use the great book of Learning Go by John Bodner. It's a great resource of Go knowledge. Okay, that's all, folks. Happy coding. Thanks for today.